Good evening, everyone. My name is Danny Wong, and I'm the Tech Support Engineer from Supergeo Technology Technical Support and Training Center. Today, our topic is Manage Image Data with SuperGIS Desktop. Within this lesson, we're going to go through the first part. We're going to talk about the introduction of image data in GIS and talk about the basic preparations and background knowledge of the image data set. And the third part we're going to talk about, which is actually a live demonstration. We have varieties of the live demonstration about image processing with SuperGIS Desktop, which will include the image display, the image processing, and image analysis. So first, we're going to talk about the image data in GIS. The image data in GIS are mainly produced by optical or electronic sensors such as the spaceborne satellite sensors, which we put all the sensors on the satellite and we launch it into the space to collect the data for us. And also the aerial sensors, which you could easily explain as aerial camera and take the aero-photo for us, and some of the ground-based sensors. And all the data set in the GIS, which could be called as a raster data set or the image data set, is basically composed of the electromagnetic spectrum data set, which have different bands in the spectrum. And all of the data above, we just mentioned above, which could be called as the remote sensing data, which we collect all the data by the method of the remote sensing. And what is a remote sensing is that this very simple explanation is that we collect the data from a distance in the remote way, collect the data, and we haven't touched it, we haven't getting close, and so within the distance we can collect all the data we need by the method we call the remote sensing. Now, some image data in the GIS, which is very common image data, include the satellite images and the aerial photograph. Some of them, like the file format, is like a bitmap, BMP file, and the JPEG file, TIF file, and PNG, and etc. And within the SuperGIS Desktop, the main image dataset will be saved as the SGR format, which you can see around here, the SGR format. And about the two common dataset within the GIS, the aerial photograph is a very useful and very easy to use dataset, which is much earlier than the spaceborne sensors, which the first aerial photo was taken in 1858 in France. And the advantage of the aerial photos is that the spatial resolution will be mentioned later on is comparatively high, and it has a variety of usage, but like some of the photograph of the cities, of the sea, or some of the scenery, but it has the limitation of it is going to be more regional due to the limitation of the carrier, like aircraft or some of the UAVs or some of the balloons. And the second is the satellite image, or the satellite sensors. Since it has started as the October 24th in 1946, it is much more lately, and it is carried by artificial satellites, which we put all the sensors, various sensor on the satellite, and we launch it into the space. So all the data collection is in the space, and could be saved as for some of the specific purpose, such as the surface temperature, the land use change, and to find out the ocean color, or even in some military use like a warfare. And it is a very lately technology and very useful within nowadays. And here we're going to talk about the spatial resolution. The spatial resolution is actually could be explained as the number of pixels utilized in the image, in a specific image. And the high spatial resolution image are composed by more pixels than the low spatial resolution image, which you can see that in the modest, which is the one of the satellite image, satellite sensor image, and so you can see the spatial resolution is 500 meter. So you can see it's comparatively not very clear, and the Landsat is 30 meter. The spatial resolution of the Landsat is 30 meters. So you can see the ground can be shown in the comparatively high, very clear appearance. Now, some of the image will need the post-processing, like aero-photo, which will be really completely will need some of the image post-processing, which you can see this is very twisty, and so you have to do some of the post-processing to make it right. And so the include the the satellite images or some of the aero-photo will need to will need to be processed by the workstation or maybe server, some of them, and to like calibration or the ortho rectification. So you can see that after all the post-processing, we can have some of the image product like one or two of these, or some of the very high resolution images. So, but in the in the field of GIS, we're going to talk about mainly about the product use of the image data set from just both of the aero-photo or the satellite images. So actually, the image processing within the GIS is about to the appearance fixing and enhancing, like the Resample or some of the other classification. And we also can do some of the automatic identification. And some of the method within the image processing in GIS is like image restoration, the image enhancement, and to do some of the classification of the pixels or the land use, and extraction. So here we're going to talk about the image process with the Super GIS Desktop. The Super GIS Desktop is a very powerful and easy to use GIS desktop product, which can, in the field of the image dataset processing, we can do the image display, the processing, and the analysis. Both of the aerial photos or the satellite images could be processed in a very easy way. So please, let's move on to the demonstration part. We're going to talk about each of the different function to manage the image data within the Super GIS Desktop. There will be three big demonstration part we're going to show you, and first we're going to talk about is the image mosaic. The mosaic function is actually perform a merge dataset result in the input of the input images, which you can see if we input two different part of the image, and using the mosaic function we can perform a merging and into a output raster, which will be shown in the demonstration. And to find the mosaic in the Super GIS setup, it is very important to open up the Super GIS toolkit, and you can find the mosaic function within the data management tool, and entering the raster processing, and you will find out the mosaic. And within this function, you have to input the image to mosaic here, which could be several of them, and also some of the options could be switched to due to different usage. And the output cell size is also customizable, which if you want to change the cell size. And so now I'm going to move on to our desktop and show you how it does. So let me open up the I'm going to open it up the Super GIS Desktop. Which now you can see I'm actually starting it. And because I want to save some of the time, so I'm not going to input all the data one by one, which you might be learn how to input the data from the former chapter. So now I'm going to actually I have already saved a project file, which is here. You can see the demo one here. I'm just going to open it. So now you can see there are three satellite image within this project, which has, I'm going to show you the satellite image 1, which is here, and the satellite image 2, and the satellite image 3, which you can see it is actually three different separate part. So now I'm going to open it up the Mosaic tool to put all these three different separate images into merge it into the one image. So what I'm going to do is to right click on the blink part and open it up to Super GIS Toolkit. Open it up. So you can see there are varieties of the tools within this toolkit, and what we're going to find is the Mosaic tool, which is actually within the data management tool here. Tap on it, open up, and now you can find raster, which is our purpose. What we're going to do is to process the raster. And here you can see the raster processing. Open it up, and now you will find out a lot of the tools we're going to use today, which is now we're going to use the Mosaic tool here. So you can simply click on it, and here you can input the raster like I'm going to. You have to be very careful of the raster input. You have to input all of them, and so then you can perform the merging. So now I'm going to be answering the image 1, image 2, and the image 3. Now roll down a bit, you can see some of the options like the pixel type, what kind of the pixel type you want to generate, and as default the setting is the byte, and you can also change by a different usage. And the mosaic mode, you can change it due to the what kind of the mosaic mode you want to use for the overlapping zone. Like some of the overlapping zone, you want to use the first one or the last one, or you want to blend it or not. So I'm going to use the default. And also the mosaic color map mode, it will allow you to switch between different options. That the mosaic color map you want to base on the first map or the last one or some of them. And here the output cell size is also you can change it. It is optional options you want to change or not. Like I'm not going to change it, so I'm using the default. And now you can see this is an output raster, which will be saved as the result will be saved as where you decide. I'm going to tap on it and select here. Now I'm going to name it as the set image merge. Okay, you can see now this is my file name. I'm sorry about the Chinese of my user interface, because I'm using the Chinese window within here in Taiwan. So you can see the main UI has is the English, but I'm sorry about the user interface of my computer. So you can tap on the save button. Now you can see I have already finished all the options, and you have to be you can also change the different the gender of the different image, which will have some of the influence of your result. And after that, you can tap on OK. So you will see it's going to be running. You have to be very careful because the image data set you're using, if the resolution of the image data or the file size is if it's really too big, it will have actually take you some of the time to do the process. So now you can see this has been finished. I'm going to close it. So now I'm going to check out the result. So now you can see this is the result. It has been merged into one piece. Then you can see. Then I can also remove list of 3. So now you can check out that this is the actual result we're being Mosaic. Now we're going to head back to the site. Now in the second part we're going to talk about, which is the image clipping, or you can say as the image or clip or the image clipping, which is actually that create a new data set by the clipping function from the input image with the specific extent, which you can see as the picture below. If we can also clip some of the area, the regional, and clip it and to become a new data set. And to do the clipping, we have a clip tool, which is also in the data management tool and within the raster processing. You can find out this one, and you can input the date raster here, and also you can decide the extent by the different. You can buy some of the raster data or buy some of the polygon data. Also, you can decide the extent if you want. And another part of the image clipping is that the advanced image clipping is by the shape, to use the shape to extract the field you want. It could be a circle, rectangle, or polygon, etc. And each pixel will be identified based on its center, whether it is located inside or outside. You can see the picture below that if this one is the input raster and this is the shape we want to extract. So you can see if the system will automatically overlap and output the raster. Like some of them, if this one is not in the polygon, the center is not in the polygon, so it will be as a no data, and some of them will be extract. And to do the image clipping by the shape, you have to open it up, our spatial analysis tool, and using the extract function, extract by shape. And this one will be a little more complicated. Will also be demonstrate in the following. So now let's head back to our Super G desktop here. Now, as you can see that if you want to demonstrate a little, I'm going to demonstrate how to extract by as a rectangle here. So which I'm going to demonstrate here is I'm going to generate a grid here. So now you can see I'm actually doing this, and I'm going to generate at a 10 times 10. We're going to be 100 grid. So I'm going to tap it OK here. So now you can see we have 100 grid here, and I'm going to change the outline color, so now you will be seeing much more clearly. Now you can see I have already separated this space into 100 grid, and I want to select some of them. Like I really want to know about this place, so I'm going to select this one, these three grid, and export it. I'm just going to use the default setting. So now you can see this part has been selected and exported into another layer, and I'm going to remove the original one. So now you can see this is these three. I'm going to extract this region. So you can also use our Super G's toolkit, and you can find out within the raster, the data management tool, the raster processing here. You can find out the function clip here. Tap on it. Now you can see the input raster. I'm going to input this one, and the output extent, which you can select between different varieties of a different layer, or even you can open it up to select between different data set, or you can enter the output extent by yourself. Now I'm going to use this one, which I just generated the grid here. I'm going to use to extract these three, the space of this three, and output. I'm going to just use the temp here. So now I can press OK. So now you can see it has been done, and let's check if the place has actually been extracted. You can see now, if I move this layer up a bit, you can see, yeah. Okay, cool. So now you can see the place has actually been clipped out, and save it into another file. Okay, now I'm going to remove these two and take back the main one. So now you can see we have back, and now I'm going to demonstrate the part 2, which is to do image clipping by polygon. So to perform image clipping by the polygon, you have to open it up, our spatial analysis tool here. You can see spatial analysis, tap on it, so it will be open, and here, and now you can see that I'm going to open it up, the extraction tool here, to find the extraction tool and extract by shape here. Tap on it. Now you can see the input raster here. I'm going to use this one, and also if you have different band, you can see within this, which in this image we only have 1 to 3, which is the RGB, and the input feature. I'm going to enter it. So I'm going to enter it. Oh, I'm sorry, I haven't forgot to enter it. So you can also enter it by this one. I'm going to use this clip village here. Open it up, and you can decide the extraction area, inside or outside, and whether you want to put. I'm also going to put it as a temp here, just fine. So you can see a little bar here, and it will be finished. And if you check it, you can see that actually has been extracted by a polygon, which I'm going to add in that polygon here. I'm sorry, I just forgot to add the polygon within. So now you can see that actually what I'm doing is to extract this the region of this polygon here, which is actually a village of the new Taipei city in the Shenzhen area. What I just do is to extract this area, the aero-photo of this area. So now you can see very clear that this part has been extracted. This is the original one, and this one is the region I've been extract. And if you zoom in a bit, you can see the within the border, it is actually mainly extracted by the polygon. Now you can see very clear. Okay, so now we're going to head back to the site. In the third part, what we're going to demonstrate is actually the image resample. The image resample, or it is a very needed process to enhance or to adjust the appearance of the dataset, which within the image. Here you can see that this is the original one, and if you do some of the resample, you can see the image will be enhanced or to adjust some of the appearance you want to see. And the process of the resample is mostly like replacing between the pixel, and you can replace the pixel within the neighborhood, or the neighbor pixel, or some of the other neighbor. And the resample data or the resampled image could be either finer or rougher compared to the original image due to the options you have been set up, like you want to refine it, or you want to lower down the resolution. It could be changed. And actually there are 4 different resample methods within the Super GIS desktop, which is the nearest neighbor, the bilinear interpolation, the cubic convolution, and the majority interpolation, which you can select between 4 different resample methods if you're doing this process. And now you can see if this one is the input image, was the original one, and the nearest neighbor. The result is made like this, and the bilinear will be like this one, and the cubic convolution will be like this, and the majority interpolation will be much more the contrast will be much more enhanced, but it will be not very clear. So you can select between 4 different methods to do the image resample, which you can also find the image resample tool within the data management tool here, and within the raster processing you can find this, and you can select between 4 different resampling method, and also you can change the output cell size here. And also, if you don't want to generate a new data set, you just want to modify the appearance on the screen, and so you can able to change that within the data properties in the display tab, and you can change the resample method. You would only affect the data that display on your screen, so it won't generate a new data set. This is another mention about the image resample. So now you can see this is the original data, and after some of the resampled image and some of the option set up, you can see that this is between different. This is the original one and this is resampled one. You can see the contrast has been comparatively higher, and is going to be some of the difference between the original one and the resampled image. And also we're going to talk a little bit about the image filtering here before our demonstration. The filtering, which is the image filtering, is also a kind of resample method, but it is a little difference that the main purpose is to reduce the noise or to strengthen the boundary, which you can see some of the object within the image or some of the borderline. It is going to from the image filtering, the advantage will be to reduce the noise within the full image and to strengthen up the boundary, which actually have two kind of the different filter, which is the smoothing filter is good at to reduce the noise, and another filter is the sharpening filter is good to enhance the boundaries. So now please let me head back to our Super GIS desktop here, and now I'm going to demonstrate you is the resample. I'm going to delete these three first and add in our demo region here. I'm going to use this part, which is actually the center part of the big image. Now what I'm going to do is to open it up, our toolkit, and find out this one within the data management tool, within the raster processing. You can find out the resample tool here. You can see now, okay, this is the resample tool. Now you can input the raster here. I'm going to input this one, set image 2, and select between the resampling method. I'm going to do polynomial here. And also I'm going to, because I'm going to demonstrate you if you change the different output cell size, it's going to be changed within the result. So I'm going to change it. You can see within this set of images, you can see you will find out that the spatial reference, the spatial resolution is 0.5 meter, because it's kind of a very clear set of images. So I'm going to change the cell size into 5 meter. Okay, 5 meter. And also I'm going to save it if you want, and you can change the direction, change the director. I'm just going to save it into the temp. So I'm going to press OK here. Now you can see this one is the output raster, which we actually finished the resample. So this is the original one. I'm going to zoom in a bit, so you can see much more clear. This is the original one, and this is the resampled one. So we can actually change the resolution if we change the cell size. And now I'm going to demonstrate you another one, which I'm going to reduce the cell size here, and also I'm going to change between different resample method, which this time I'm going to use the nearest here and input data and the set image, because the original is 0.5 meter, so I'm going to change it into 0.3 meter. Also I'm going to save it in temp. This time will be a little longer than the original one, because you can see that actually the pixel has been modified. You can see this is the original one. Okay, I'm sorry, this is the result. You can see the pixel has been reduced and pixel size has been reduced, and this is the original one. This is what we have just done. And if we zoom out a bit, you can see that it's quite just a little difference, but it will be much more clear in the border. It's the original one. Okay, now we're going to head back to our slide. And the fifth part we're going to talk about is the pen sharpen. What is a pen sharpen? The pen sharpen is one of the image fusion method within the image processing. What it actually do is to fuse a high resolution and panchromatic raster dataset with a lower resolution multi-band raster dataset, which you can see this one is high resolution. Spatial resolution is much more higher within this. You can see just white and black panchromatic raster dataset. And also, if we have a lower resolution multi-band raster dataset, which you can see as a RGB or much more band within this image dataset, and would be color. And so we can fuse these two image dataset into a much more higher resolution image dataset with the color, with the multi-band. And the result of the pan sharpen process is to make the image more distinguishable with the surface and the nearby object, and some of the contrast will be enhanced, and also the visualization effect will be enhanced, and to improve the color quality of the images, which you can see this is the panchromatic one, this is the original one. And so after the pan sharpen processing, you can see the resolution has been raised significantly, and the borderline and also the object within this image will be more distinguishable. So you will also find the pan sharpen tool within the data management tool within our toolkit, and entering the raster processing, it will easily to find the pan sharpen tool within it, and you can simply open it up, and also you can find it very easy to use within this tool. So now please allow me to head back to our SuperG's desktop here. I'm going to close this one and open it up a new one. I'm going to open the demo tool here. I'm not going to save into the first one here. Okay, now you can see that within this project I have already put two different images, which is this one is the panchromatic image dataset from the GOI. These two images are actually from the GOI, and it is a little difference between the RGB different band and the near infrared. So now you can see this is actually a black and white panchromatic dataset, which if I zoom in a bit, you can see that the spatial reference is actually much more larger. You can see this one. So I'm going to do a quick measurement that tell you the spatial reference. It is actually 1 meter, around 1 meter. Okay, I'm going to close it. And I'm going to switch into the different one. You can see this is actually you can see it's a black, because due to we haven't changed any properties of the display and symbology. Which here I'm going to switch. I'm going to change the switch type into the minimum and maximum. Apply it. So now you can see, oh, okay, this is the image dataset from the GOI, but the color is quite different from the some of other image data because we haven't changed the display, the band of the the GOI. Actually, the blue is the band 1, and the red is the band 3, and the green is just stable on the band 2. And you will find out that it will have the band 4 here. It is actually the near infrared. So I'm going to change it and apply it. You will see that, okay, now you can see the image has been changed, and this is the foreign part, and it's actually much more clear than the original one if we haven't changed the band setting. So now you can see this is actually, I think it's a school here. And if I open it up, panchromatic one, you can see the resolution is comparatively higher than the color one. So you can see this much more. You cannot see very clearly. And if I open up the panchromatic one, you can see this is a school, and it is much more clear. And so now we're going to perform is the pan sharpen. I'm going to pan sharpen the original data within this panchromatic image dataset and fusion it into a much more clear and higher spatial resolution color dataset. So what I'm going to do is to open up the SuperG's toolkit again. You can find out in the link here. Right click and select the SuperG's toolkit. Tab on it. and open it up. The tool is also located in the data management tool here. Enter it, and you will find the raster tool, the raster processing, and now you can see the pen sharpen tool is actually within this folder. So you can simply just tap on it. Okay, you can tap on it. Now in the first option, you have to input the raster data, which is the color one. You can see this one, BGRN. Okay, here. RGB and the infrared here, and the input panchromatic raster data. You can input the this one. So I'm going to input these two data set, and you can see that the pen sharpen type here. You can select between the Brave, which will significantly increase the contrast of your result. Then the IHS is to transform the RGB color into the IHS color axis, and the main is the basic one. So I'm going to use the main with just mainly to reperform all the RGB, and so I'm going to use this one. And also there will be 3 different options of the red weight, the green weight, and the blue weight, which if you're likely you don't want to change anything, you can simply just press, you can simply just use 1 and 1 and 1. But I think within this is actually a rural area, I'm going to use more weight in the green here, so I'm going to use 10. And this is the output raster. I'm going to save it as just like pen sharp. Sorry. Pen sharpen. Okay, pen sharp. Okay, it will be fine. And select. And so you will have already finished all the setting, and after that you can select the OK button and wait for it. Because there are special reference of the GUI and the image of the image set data set of the, or you can say it as an image product of the GUI is much more, the file is much more larger, so you might have to wait a little longer than some of the file which is actually comparatively small. And you can see this has been a very large area, which is, I believe this is in Taiwan, and in the Taiwan's river area. This is the river here, and you can see that in this river area, some of the villages was within this part and this part. Okay, so you can see that we have been finished, and you will find out that it will be a black square, having no any other color, which it reminds us that we also have to change between the properties here. We also have to change the stretch type and apply it. You can see, okay, now this is our product, and also the band will be due to limitation of the GUI. You have to change the red and the blue band into blue is number 1 and red is number 3. So now you can see, okay, this is our product here. I'm going to zoom in a bit. Okay, so I'm going to move along a little bit so that you can see more clear as we find out this part. So now you can see this is our product. This is our product here, and I'm going to find that school. Sorry, a bit hard to find. Okay, I think that it's okay that if we zoom in into this part. Okay, now you can see this is the actual result. Okay, now you can see this is school we just mentioned. This is the result of our pen sharpen. So now you can see this is the result. This is the pen sharpen original file, the panchromatic file, and this one is the original image data set. So what I'm going to do is to compare you the different the former and our result. So now you can see this is our former, the original image data set, and this one is the panchromatic one. And after that, after our process of the image fusion, the pen sharpen, this is our result. So you can see very clearly that the resolution has been significantly increased, and also it has been you can see that it has been compared to the panchromatic image data set. It has been fused with the color data. It is very useful and very convenient tool. And also all the options within the pen sharpen, like the red and the green and blue weight, could be changed due to different usage. Also the pen sharpen type, you can select between three different options of the usage you want to perform. And the sixth part we're going to talk about is the grayscale. What is a grayscale? The grayscale tool is actually convert the input raster, which you can see within the picture below our slide. This is the input raster, and turn it into a grayscale raster. And it is actually what we're going to do. What we're going to perform a grayscale if the original data is full of color. Well, the actual main purpose is to reduce the complexity of the original data, or we want to, if our process needs to improve and to increase the contrast of the input raster. And so it is actually visualize the intensity of the pixel between the white and black, because this is full of the other color. And if we just want to find out some of a pattern, or want to classify, you can use the grayscale tool to convert the original color data set into the grayscale data set. And also you can find out the grayscale, the data will be also located within the data management tool within the raster processing. You can easily find out this one. And so now I'm going to demonstrate this part. So we're going to switch to our Super G setup. Okay, this is I'm going to open up the demonstrate here, the project here. Cool. Now you can see this is another satellite images, which is this one is not the GeoEye, but the Formosat-2, which is the a satellite which launched by a satellite sensor which plays in a satellite, and the name of it is the SatNav-2, which composed and built and designed by Taiwan. So now you can see that this is actually our data within here in Taiwan. And also, okay, so now what I'm going to do is to perform the grayscale. So to perform it, you can also open it up, the Super GIS toolkit here, open it up and find the grayscale tool within the data management tool, the raster processing. You can find out there's a grayscale tool here. Simply tap on it. Okay, now you can input the raster here. Tap on it and select. I'm going to use this one because I may name it into NDVI because I'm going to demonstrate of the NDVI in the following. And so here you can select between three different method, which is the standard, the weight as a weight, or the normalization. I'm going to use a standard here. And also you can enter the band weights if you have different band weight of the you can select the weights of the different bands, which I think within the SatNav, the sat image of the Formosat-2, there are 4 different bands, which is the RGB and the near infrared. So I'm going to enter it as a 1 and 1. I'm sorry, I'm going to use 10 of the NR band. So you can see the RGB and the NIR will be 10. And also you can select the place you want to put. And after that, you can tap on the OK, so it will actually perform it. So now you can see this is the original one, which is the color map. And this one is the grayscale image, which you can see in some part like the trees. You can see this is the tree top of the forest and some of the tree with along the river. You can see it has been actually the contrast has been increased, and so the If you're doing some of the classification of the different kinds of the tree, or some of the different classification of the land use, so it will be much more easier if you grayscale to perform a grayscale of the image data set. So you can see that this is the original one, and this is the what we perform as a grayscale. Now I'm going to remove it and head back to our slide. Okay, this is going to be the final part of our demonstration, which is actually the NZVI. What is the NZVI? Is the Normalized Difference Vegetation Index. We have a variety of the vegetation index or some of other index, and it is actually in this one is actually mainly about how to find out where the plant is, where the vegetation is. And it is a normalized ratio of the NIR, which is the near infrared, and the red bands. And it's a very good vegetation measure method, which you can sufficiently stable and to permit the meaningful comparison of the seasonal and the inter-annual change in the vegetation growth and the activity, which you can find out. It allowed you to find out the vegetation distribution within the a region, and you can also find out the changes of the vegetation, the growing of the vegetation, and you can find out the formula is this one. The NDVI is actually the normalized ratio of the NIR and the red bands. And what we're going to find out is actually to find out using this ratio to find out where the plant is on the image data. And the NZVI is very widely used in varieties of operational application, include farming early warning system. You can find out the plantation, the growing of the crops. And we can simply use it as a land cover classification to find out the rural area, to find out the forest, to find out where the plant is, and also some of them like health and epidemiology, and the drought detection, and some of the land degradation and the deforestation, which is mainly you can find out the forest the decrease of the forest area, which is a very important issue within nowadays. So now you can see within the picture in our slide, if you join the red band and the IR, which is near infrared, you can find out where the plant is. So within our toolkit, you can also find that NZVI tool is within the data management tool here, and within the raster processing, you can find out the tool of the NZVI here. So what I'm going to do is to perform this part of the demonstration. Now, I'm going to head back to the full extent. Now, before we can use the NZVI tool, which you can see within the data management tool, the raster processing, if you click on it, it will need you to input the infrared band and the red band. And also you can select between to input the cell size, the offset of the cell value. But you can see that we only have one image data now, so we cannot input the infrared and the red separately. So one thing we're going to do is to extract the different band of this image. So to do that, we have to open it up the SuperGIS spatial analysis tool here. And the layer, you can see I have selected NZVI here, which is this layer. Once again, this layer, this setup image is actually the product of the Mosaic 2, which has contained of 4 bands, which is the RGB red, green and blue, and the near infrared. So what we're going to do is to extract the band 1, which is the red, and the band 4, which is the near infrared. So all I'm going to use the extraction here, and using an extraction, I'm going to use extract by attribute here. So you can see now here, this is the input raster, but within this little icon here, we can select between different bands. Now I'm going to only extract the band 1 here. So now you can see the band 1 has been clicked up, and this part I'm going to use a sickle. I'm going to just use to extract all the value. Okay, to extract all the value, or maybe you can simply just enter it like it's going to larger than 0 or something, and the output register, I'm going to save it as a temp. This is okay. So now you can see this one. Okay, this one is actually the red, so I'm going to just okay, this one is a red, so you can simply tap on the properties to see what it's like, and here you can see the title. I'm going to change it into red to indicate me this one is the band of the red. And actually another thing I'm going to do is to extract the band 4, which is going to be in this and we have the original data set, and select the band 4, which is the near infrared. So what I'm going to do is extract all the value of this data set and tap OK. So it will be extract. So this one is the near infrared. So I'm going to change it to indicate me this is going to be infrared. Okay, so we have the red one, we have the near infrared. So now we can use our tool of the NDVI here. So tap on it. So here I'm going to enter the near infrared, and are here, and the red band here. Okay, the offset I'm not going to enter any of the options, and I'm also going just to save it as a temp here, or maybe we can save here, like I'm going to save that NDVI result. Okay, it's R means a result, and press save and press the OK button. So now you can see this one is actually the result of our NDVI. So what I'm going to do is to turn this to off and let you to compare this is the original one, and this is the result. And because it's shown in the black and white, so we cannot actually see very clear, because actually the white part of the image is actually the plantation. And so I'm going to change the symbology here. I'm going to change the color into green and red. Okay, so you can see now that actually the green part, okay, the green part is actually hasn't got any plantation or the vegetation, and the red one, the red part here, is actually where the plantation is, the vegetation is. So you can compare that. This is the forest and this is the rural area. So if I switch into the NDVI result, you can find out that within the river there is some vegetation and plantation within this river part, and this part is a forest, is very clear. And if I move along a bit, you can see now that this one is actually a forest area, and this one you can see that within the result of the NDVI you can find out where the vegetation or the crops or the plantation is. It is very useful tool to find out that within this rural area, well, in which farm hasn't got any crops, and within some of them has some of the crop plantation. You can find out. It's very easy and very useful tool to find out where the plant is. Now heading back to our slide, so this is going to be our review. And so within today's lesson, we talk about the advantages of the image dataset. To use the image dataset, we can do various kind of the usage due to a different purpose. And also there are varieties of source and application of the image data, which come from the aero-photo or come from the satellite image, or maybe some of them come from the ground-based sensors. And all the data set, raster dataset or the image dataset, you can manage all of them with SuperGIS Desktop with ease, and it is very convenient and very powerful tool to manage your image data with the SuperGIS Desktop. Thank you. This will be today's lesson, and thank you for your attention. And if you have any question, please contact us at www.supergeotech.com or email us at step@supergeotech.com. Thank you.